In the shadows of the Space Needle, a naval revolution is being welded together. It isn't happening at Huntington Ingalls. It isn't happening at Bath Iron Works. It's happening at a commercial barge facility in Seattle, Foss Shipyard. While adversaries count their multi-billion-dollar holes, a Silicon Valley defense outlier is quietly producing something far more dangerous. Anduril is building the United States Navy's first truly expendable destroyer fleet, and they are doing it for a fraction of the cost. A fraction of the cost. Traditional shipbuilders require years, decades. This commercial facility requires months. But how does a tech company bypass the entire military-industrial complex to build autonomous, lethally armed vessels disguised as commercial logistics barges? The answer isn't in the steel, it's in the software, and it is about to render traditional naval warfare entirely obsolete. The modern United States Navy has a mass problem. An Arleigh Burke-class destroyer displaces 9,500 tons. 9,500 tons. It cost over $2 billion. It takes 3 to 5 years to build. If we lose one in the Pacific, it leaves a massive hole in our defensive umbrella that cannot be replaced in wartime. Our adversaries know this. They have optimized their anti-access area denial strategies around the very specific mathematical equation. Missile salvo quantity plus hypersonic velocity divided by Allied interceptor capacity equals fleet destruction. They believe they have solved it. They calculate that overwhelming an Aegis radar system with cheap, mass-produced munitions across a 2,000 nautical mile kill chain guarantees victory. A carrier strike group can only stay at sea for so many days before expending its vertical launch systems. 90 days at sea. 90 days before they are effectively disarmed and forced to withdraw. The math currently favors the adversary. The traditional U.S. shipbuilding apparatus is too slow, too centralized, and too expensive to change the variables. To break the adversary's equation, the Navy doesn't need better destroyers. It needs disposable ones. We must compare the architecture of legacy survival against the architecture of deliberate attrition. A traditional destroyer is a centralized monolith. Its hull houses the radar, the crew, the combat systems, and the kinetic interceptors. A single penetrating hit cripples a multi-billion-dollar asset. It is a single point of failure. A single point of failure. The Anduril concept strips this down to its engineering truth. They are utilizing commercial barge hulls, flat, unarmored, displacing roughly 3,000 tons. Traditional warships use HY-80 high-yield steel to survive blast overpressure. Foss is welding standard marine-grade A36 steel. It is not built to survive. It is built to shoot first and die. The propulsion relies on off-the-shelf commercial diesel generators feeding electric azimuthing podded drives. This completely removes complex mechanical reduction gears. Reduction gears are the biggest production bottleneck in modern naval shipbuilding. By eliminating them, scale skyrockets exponentially. But the real magic is in the payload modularity and Anduril's Lattice operating system. These aren't ships. They are floating server racks for weapons. Instead of Mk-41 vertical launching systems permanently embedded into the keel, these autonomous vessels carry containerized missile pods, standardized shipping containers hiding long-range anti-ship missiles. Because there is no crew, there is no life support, no galleys, no berthing. That eliminates 60% of internal volume requirements. 60% of internal volume requirements. This allows for massive fuel reserves and extreme weapons payload density. The doctrinal feature that alters the tactical math is distributed lethality via sensor-agnostic launch. The expendable destroyer does not need an SPY-6 radar. It receives targeting telemetry off-board from an F-35, a satellite, or an underwater drone. When the launch platform is a silent, commercial-grade hull that costs $20 million instead of $2 billion, the cost-exchange ratio violently inverts. Let's execute the wargame. The theater is the Philippine Sea. The objective: break an enemy naval blockade without risking a Nimitz-class carrier. Here is the interlocking system at work. Step 1. The silent dispersal. Weeks before the kinetic phase, 6 Anduril expendable destroyers deploy from Seattle. They navigate autonomously at a cruising speed of 12 knots. Because their radar cross-section mimics commercial traffic and their acoustic emissions are negligible, they blend into the maritime background noise. They pre-position themselves across a 500 nautical mile axis outside the enemy's primary sensor range. The board is set. Step 2. The sensor mesh activation. The adversary fleet advances to enforce the blockade. Overhead, low Earth orbit satellites and high-altitude autonomous drones detect the enemy surface action group. The raw targeting data is instantly fed into Anduril's Lattice network. The expendable destroyers remain entirely passive. They do not emit radar energy. They do not give away their positions. The target coordinates are simply downloaded into the containerized missile pods in real time. Step 3. The overwhelming salvo. The condition chain requires simultaneous time on target. The AI calculates the exact launch sequence, accounting for varying distances to the target and atmospheric drag. Across the 500-mile front, the door-drop container doors drop. 60 long-range anti-ship missiles launch in a highly coordinated volley. 60 missiles. 60 missiles. The expendable destroyers have just unleashed the firepower equivalent of an entire Arleigh Burke squadron, but dispersed over an impossibly wide, decentralized area. Step 4. The attrition sponge. The enemy fleet detects the incoming salvo. They are forced to light up their active radars and exhaust their interceptor missiles to survive the swarm. They succeed in tracking the launch points and fire hypersonic retaliatory strikes at the Anduril vessels. The expendable destroyers take the hits. They sink. But the tactical objective is achieved. The enemy fleet has completely exhausted its magazine depth. They are functionally disarmed. The real United States carrier strike group, waiting safely over the horizon, now moves in for the decisive kill against the defenseless adversary. The math has been inverted. Wars are not won by the military that possesses the most advanced, irreplaceable artifact. They are won by the nation that masters industrial depth. The Foss Shipyard operation represents a fundamental shift in American naval doctrine. We are moving away from the exquisite and the vulnerable toward the brutal efficiency of mass and disposability. The adversary built their entire military apparatus to hunt leviathans. Anduril is feeding them a swarm of lethal ghosts. 1,000 cheap, interconnected nodes will always defeat a singular, expensive fortress. This is the engineering truth of the 21st century. Software scaling will outpace hardware hardening. The side that can print lethality faster than the enemy can track it wins. We are watching the sunset of the traditional battleship era, right on the Seattle waterfront. If this breakdown helped you understand the formula of the Foss Shipyard secret, how Anduril is quietly building the Navy's first expendable destroyer fleet in Seattle, subscribe and ring the bell to get latest Navy video.